Hello guys. So today we are going to solve famous problem is the graph bipartite. So as you know, this is a very famous problem. And first of all, it makes sense to discuss what do you mean by bipartite. Okay. So what we mean by bipartite is that the node of the graph can be put into two different sets. Okay, and there is no edge which goes from within that. Look, suppose we are putting the vertices, all the nodes of the graph, the vertices or nodes, whatever we may say, uh, in two graphs, A and B. So all the edges are in from A to B or B to A. It's not that there are edges from A to A itself. I mean to say, if two vertices, let's say 1 and 2, are there in set A, then it should not be that there should be an edge between 1 to 2. All edges should go from the vertices of set A to the vertices of set B or vice versa. Okay, it should not be that the the relationships are there from the two nodes which are there in the same set. So this problem, this looks like must say that this is a very famous graph theory problem, and how to prove this thing, how to do this check using code. So it looks, very interesting. And as always, when something which looks nearly impossible to do, what do you do? Okay. So whenever, someone asks you the question, what do you do when something nearly, you know, comes in front of you, which is of impossible, uh, kind of, uh, it looks, that, oh my goodness, this is an impossible task to do. So, I always say that, whenever you come across something which looks like impossible thing to do, think of recursion. Okay. um, you know Maybe I'm wrong, I'm not a good problem solver, but to me, it looks like that, computer science is nothing but to learn how to, apply recursion. So if you are able to apply recursion, you know how to solve problem in computer science. Maybe I'm trivializing the things. Um, I'm I'm an inexperienced problem solver. That's why I'm saying all these, bullshits. But this is my video, and when I'm creating the video, I I have the right to speak out my opinions. And I actually believe that when you come across a problem which looks impossible to solve, always give one shot, you know through recursion. What you try that, solving that problem, thinking on recursive lines. So having said all this, let's try to think of how can we solve this problem. So to solve this problem, what we are going to do, that we are going to put some number on the edge, let's say this edge, and to all the edges which are related to this. So let's say this is related to this, this is related to this, this is related to this. So if we put 1 on this, and let's say put 2 on this, so this is related to this, so this, let's say put 2 on this also. Let's say we put 1 on this, and then we'll put 2 on this, because the edge is there in between 0 and 3, in between 0 and 2, in between 0 and 1. But the problem in this graph is that 1 and 2 are also interrelated with this edge, and 2 and 3 is also interrelated in this edge. Had it been, had this graph been, it would, had it been like this, you know so suppose this graph is, how to draw, yeah. Suppose this graph, no, not like this. Suppose one node is this, another node is this, One another node is this. Okay, one more node is this. So had it been, like this, okay, then we could have said, we can have, we could have said that this graph is bipartite. But the presence of these edges, let me put a different color on that. The presence of, these edges is, not helping the cause, and it's these edges which making, this graph not bipartite. Okay, so now we have discussed this example. So let's go and draw some other example. Now let's see this example. Okay, I guess I'll have to. Oh my goodness. Okay, what to do? I want to have a look at this example. How can I? Use this? Yeah, so if you take a look at this example, then, you know, in this example, we see that the edges are like this. Second example, the edges are like this. Okay, and then the edges are like this and like this. So what we are going to do, we'll be putting one number here. So let's say we put the number, like, you know, 1 over here, okay? And since these two edges are related, so since we have already put 1 over here, we are going to put 2 over here, okay? And this is related to this, so we are going to put, again, we'll put 2 over here, okay? And this graph, this node is, not related. So this edge denotes a relationship. This node is not related to this. So again, we are, we can, but this is related to this nodes which is having value 2, and this is related to this node which is having value 2. So we can put, 2 minus 1, 1 over here. Okay. So we see that, this graph lends itself to this, uh, the scheme where we can put either 1 or 2 on the node in a meaningful way. So this suggests, that, we can have, a set like this, another set like this, okay? And we can put one node representing, one node representing this node, one node representing this node, okay? And one node representing this node, okay? And one node representing this node, okay? So this suggests, that our scheme of attaching 1 or 2 based on the relationship, like if there is a directed edge in between two nodes, we are putting, one, if the previous node is having value 1, then the node under consideration will be put the value 2. So like this, we are going ahead. Okay. So with this example, will be, Okay. So with this example, we will be, uh, we'll start, our problem solving, and let's try to solve this problem. So first of all, we'll be having one int array color, which will be having int the size of the length. Okay. And let's have one more array. So as I said that, we are going to use recursion. So whenever I say recursion, DFS, the DFS patterns would come into your mind. Okay, new Boolean, same length as the color length, because this is the number of nodes in the graph. And what we are going to do, that we will be, in for DFS, we put this int I is equal to 0, I less than visited dot length plus I. Okay, we are going to do this, and in this what we are going to do, that if visited of I is equal to, let's say visited of I is equal to false, visited of I is, so we can directly put like this, if not visited, then what we'll do, that we will put color of I is equal to, let's say initial, we'll put this color, and graph traverse DFS like this, and then we will put, we'll pass this graph. Okay, and then I, and then visited, and then this color. Okay, so after this traversal is finished, we'll check Bipartiteness on the graph with the help of color array, and if that returns true, we are going to return true. If that returns false, we are going to return false. So now, I'm going to write this check, graph traverse DFS, and you'll see that this is exactly what we learn in our, textbooks, how to do DFS. And vertex and Boolean array visited color is an int array, so we have to declare it as an int array. Color, my goodness, color. And we also have to check if v is greater than graph dot length greater than or equal to, then obviously, this is the case when we'll be returning back. and then we'll have to make visited of v is equal to true. Okay, and then for I in the graph of v, graph of v, okay, for int I of graph v, okay. So first of all, we'll check if visited of I is true, then we'll be returning, will continue, not return. We'll continue. Otherwise, we will proceed ahead and we'll check if color of v is this node from which we have come to I. If color of v percent 2 is equal to 1, so if the color is 1, then since this is color of I will be color of v plus 1, okay, else color of I is equal to, if it is 0, then we will let it be having the same color as v. So if it is 2, then it will be 2 only. Otherwise, if it is 1, then we'll be adding it to 1, or other, if it is 2, then we'll be making it as -1. So yeah, so in this way, and now we'll be after this, I think within this for loop we should be if color of I is not equal to, so we can do one more thing over here. Not necessary, too many checks are not going to help us. So we'll leave it like this. Okay, just directly we are going to call this graph traverse DFS, graph traverse DFS, your name is correct, graph v visited color, and then the final thing that we want to write is this boolean check bipartiteness. Okay, and to check bipartiteness, we'll have to pass this graph and then this entire color. So after passing this color, what we are going to do that, since the graph can have length from I is equal to 0 to I less than graph dot length plus I, if and then inside this for int j graph of I, if graph of j is equal to graph of I. If these are equal, then we are going to return false, else, as is the case, we'll be returning true. So with this, having written this, I think I have solved the problem. So let's try to run this. Oh yeah, I and T, it's I is missing here. So some problem here. Okay. Okay. So we should not be passing V over here. Okay. We should now be passing. Oh yes. So we should now be passing I, not the V. Okay. We can put one condition, but without that condition also, let me check. Okay, so now we are able to, get this thing. So what is the issue here? What would be the issue here? So to check the issue, let us, put one system.out print statement, print ln arrays.to string color like this and run this. So this one is correct. 1 2 1 2. Perfect for this case. Also 1 2 1 2. How come 1 2 1? This should give false. Oh yeah, not graph, color of, and then color of. So we'll comment out this debug statement and then we'll again run it. Perfect. So both the sample examples are running. We'll run this. Perfect. So I was thinking, one more thing to be, doing over here. So what I was thinking that, I can put one arrays dot fill on this color array and make fill this, arbitrary value -99 over here and call this ith, only when it's not equal to -99, because we are setting the color values in these two lines, on line number 25 and on line number 27. So if it is not 99, so it should not be 99, then only we are going to give a call to. Okay, yeah. So with this, let's see whether it adds some improvement in our code or not. So code is running correctly. No, not much improvement. I think we can remove this line. So even if we comment it out, it's not going to affect the efficiency of our code. Perfect. So this is one way to check bipartiteness, which I wanted to share with all my friends. And if you have any doubt, please, put this question, put comments, and I'll definitely try to answer these doubts. Thanks a lot. Thanks once again for watching my videos. I really appreciate. Thanks a lot.